Hi guys, Mathemagic here, and today I'm going to be going over calculus and showing you how it is not something that is difficult, despite all the stereotypes and the hype surrounding calculus. It's really something not to be scared of. So calculus concerns itself with graphs, and specifically the gradient of the tangents of any graph. So imagine we have a graph here. Let's just draw ourselves a parabola. We know that tangent is a point or a line that only touches this graph at one spot. There's a thick marker, but anyway, you get the point. So this is only one point where the tangent touches the curve. The x-axis here is actually a tangent to this graph. It only touches at the point where x equals 0. I can draw another one in here, This line is only ever touching the graph once. We can find the gradient of these tangents using what we know as calculus. Or a more nuanced way of saying it would be, we can derive this function here, this parabola, to find the equation of the tangent at any point on this graph. So what am I saying? So let's get right into how one can derive a graph. So if we derive this, we're going to be given a function, what we can write as dy over dx. This is effectively saying the rise over run, or the gradient of the tangent at any one point. You also see this written as f dash x. This is just another way of saying dy dx. Either one works well. It usually depends on the question. If you're given y, you use dy dx. If you're given the function of x, you use f dash x. Anyway, let's get right into how you can derive a polynomial, which is, I'd say, over 60%, over 70% of what you do in calculus is the deriving of polynomials. So if we have a polynomial, let's do any polynomial, ax to the power of n. To derive this, all we have to do is bring this n value out to the front, multiply it by the original function, and just take 1 off of this n. It's as simple as that. So let's get into an example. With our parabola here, y equals x squared. To derive this, what are we going to do? We're going to bring this 2 to the front. So we're going to get 2x and take 1 off this power. So 2 minus 1 is 1. So our derivative of y equals x squared is just 2x. It's as simple as that. That means that at any point on this parabola, let's say x equals 1, the gradient of the tangent will follow this as defined by this derivative function. So if we sub in x equals 1, I'll just write in when x equals 1, dy over dx equals 2 times 1 equals 2. So this would be negative 1. If we had x equals 1 here, this gradient is going to equal 2. The rise over run, you go up to y coordinates and you go across 1. It's as simple as that. It's defining how steep or shallow our tangent is. Let's do a more tricky example here. So if we have the function, I'll write it like this. If we have a function of x such that 5x to the 7 plus 3x to the 3 plus half x. That's half x. Just like that. How are we going to derive this? Well, f dash x is going to equal, we bring this 7 to the front, 7 times 5x, we take 1 away from the 7, so we've got 6, plus, move this 3 to the front, 3 times 3x, take 1 away from the 3 is 2. This is a slightly harder example. Well, it's not hard, it's just an interesting way to understand how it works when you've got x to the power of 1. X to the power of 1, we move that 1 to the front, multiply it by the original, and we take 1 away from this 1, so we get x to the 0. We know that anything to the power of 0 is just 1. So this is actually just going to be 1 times a half times 1 This is just a half. So whenever you're deriving a function and you've just got x with no power, you can essentially just cross this out, and you can just keep the coefficient as the derivative. So tidying this up, we're just going to get 35x to the 6 plus 9x squared plus a half. And that's the essence of calculus. Of course, it does get a little trickier when you've got functions multiplying by each other or divided, or involving trigonometry. But there's all rules. It's not hard stuff. So check out my other video where I talk about how we can further understand how this dy dx really works and how it actually came about. So thank you very much for watching.